Welcome to this Docker tutorial for beginners. If you are just starting out with Docker and want to understand how it works and what you can do with it, this is a great starting point. Let's look at the overview. So we're going to look at what is Docker. We're going to install Docker on Windows. We're going to run a little web server called Nginx, very popular web server, and we're going to be using Docker to run it. Then we're going to look at Docker volume mounts, Docker volumes, Docker logs, Docker environment variables, and then we're going to wrap it up. Thank you for watching this video. Please like and subscribe to my channel and enjoy the content. Step number 1. What is Docker? So what is Docker? Before we look at what Docker is, let's look at what the world looked like before Docker. So you would have your hardware layer at the bottom, and that would be your CPU, your RAM, maybe your hard drive, and then you would have your operating system, and that could be Windows or Linux or Mac OS. And then you would have your applications, and your applications may have like libraries that you install, other dependencies, things that could be on the operating system. And that's one of the problems. If the operating system, for example, was upgraded, sometimes your application would break. There's often differences between the developer's machine and what's installed on his machine and the server, and there was often challenges when you deployed applications. And what Docker did is insert a layer in between your application and the operating system and the hardware. So you basically have the same basics. So you have your hardware and your CPU and your RAM and your hard drive. You still have your operating system, which is Windows or Linux, and Mac. It's also possible. And then you have Docker or containers. And then Docker runs containers in each of these little boxes. Okay. So what is a container really? Well, in Docker you have got the concept of an image. Okay. And an image is like a blueprint for the software. It contains all the application code, the libraries, the dependencies, and it is wrapped in like a virtual type of container or image. And then every time you start the container, any one of these containers that you start from an image, you can start one or multiple instances of the same image, and that is called a container. So these little blue boxes are your containers. And you usually interact with Docker through the command line. So the Docker layer has a CMD, a command line. There's also graphic user interfaces for this, but what we're going to be looking at in this tutorial is how to use the command line and how to do things from there. Step number 2, let's install Docker and run our first Docker commands. Okay, let's install Docker. So we're going to go Docker install and click on Get Docker. And there's usually a couple of options. There'll be a Mac, a Windows, a Linux version. I'm on Windows. So we'll click on the Windows version and then we click on the file to download it. I have already downloaded the file. So I'll be using the file in the next moment to install Docker. So when you're installing Docker, depending on what version of Windows you are and what version of Docker, I'm on the latest version as of today, which is 4.8.2 for Docker. And I do have Windows Subsystem for Linux 2 enabled with Hyper-V, and I do not want a shortcut on the desktop for myself. You may want that. And then if you click continue, it will then unpack all the files and install it. So once it's finished installing, you should see an install succeeded box. You can close that window. And then if you open a command prompt, what you can be doing is just do a docker -v. Once you've done a docker -v, you will see the version that you're running of Docker. Once Docker is running, you'll see this little blue icon either in your taskbar or where the icons are, your icon bar, and you can read the license agreement. I'm just going to accept the license agreement and continue. You will then see Docker Desktop is starting. This takes a little while. And then once it's started, there's some tutorials that you can do there as well, but I would just skip over that. The main thing I wanted to check in the settings, and I don't really care about the tips, is do we want to start Docker Desktop when you log in? I don't. So when I log in, I want to manually start Docker Desktop, else it will automatically start once you log into Windows. There isn't really much anything else that I want to look at the moment, and we should just be able to close the application and then do a docker ps, and if that works, it does, then we can continue to the next step. So the first Docker command we would like to run is to run a Hello World application. That's all-time favorite for most developers. And how does this work? So Docker starts with the word Docker. We did -v just to test that it's working. And we looked at the processes, but we'll look at that a little bit more in a moment. So we say Docker and run, and then the name of the image that we would like to run. Now, sometimes there is a tag on it, and it could be latest, or it could be version 1, or it could be a variety of things. But in this instance, we're just going to run the Docker run hello world. Now what it will do is it will see there is no image on my local host on my machine. It will then go to the Docker Hub, which is a repository of images where a variety of companies and individuals can post images or push images to, and then when you give the name hello world, it will go and find the image, download it, and then run it. And when it runs it, it prints out this text message. One of the things to then look at is a command called docker images. And in docker images, we'll see, well, there's a hello world image that was downloaded. And there's another docker command, docker ps, which lists the current containers running. And we'll see, well, there's no container running. If we do a ps -a, it will give us a little bit more information. We can see, well, this was the container that ran hello world about a minute ago, and it exited because it just printed the message and then it was done running. So throughout this tutorial, we'll be referencing this cheat sheet. I'll put the download link for the cheat sheet in the description, but it basically gives you a summary of most of the commands we'll be using. There's one or two that's not in here, but this is a good starting point. So now we've run our first container, and what we'd like to do now is run something a little bit more complicated. So we want to look for Docker SQL Server, and what we'll find for the Microsoft SQL Server when we search for it, the Docker repository, which is called Docker Hub, will tell us a little bit more about images that's available. This one is made by Microsoft. It is Microsoft SQL Server. And just to show you how easy it is to run SQL Server using Docker, we'll run the Express edition because you don't need a license for that. It's free. And we're just going to copy the command, paste it, and there's only a little change we need to make. It's just here where the password is. I'm just going to change the password to strong at password 123. And let's just look at the commands a little bit. what does each section mean? So we already know about Docker and run. Run means we're going to run a container. The -e is an environment variable. So we say we want to set the accept ULA, so it's the end user license agreement. That's what that stands for. But that's something specific to SQL Server, is that we've accepted the conditions, the terms and conditions for SQL Server. And then there's yet another environment variable called SI password, which we have set there, but I see I've made a little typo, strong at password 123. So there's yet another environment variable, MS SQL PID, and this is the version of SQL we want to run, which is Express. So there is another parameter that maps the ports. So this is the -p part. The usual SQL Server port inside the container is 1433, and we're saying on our local host we want the same port to map to 1433. And then the -d means we're running it in the background, and then the container name or the image name is this long name, and the tag, which we talked about before, is that we want to run SQL Server 2019, the latest edition. There's SQL Server 2017 and a couple of other editions that we can run. So if we press enter, when we get to the end of the command, press enter, same thing will happen as before. It will not find the image. When it doesn't find the image on your local host or locally, it will then go and download the image. So to test SQL Server while it's busy downloading there, I'm going to run SQL Server Management Studio, which is a separate desktop application that will actually enable you to connect to SQL Server and run SQL commands and create databases and do all types of fun stuff. Just wait for it to start. So SQL Server Management Studio has started. We're going to try and connect to the local host. And we're just going to use the strong password that we have here. And if we connect, it will not work at the moment. So we can't connect because the server isn't running yet. So I'm just going to pause here for a second. And when it's finished downloading and installing, we'll just do the test to see that it's running. Okay, it's finished downloading, and if I do a docker ps, I will see that the container is running. All looks fine there, and we should be able to connect to the database engine. It's localhost. If you are using SQL Server Management Studio, just do note that this password is for the super user. It's not a domain password. And if we click connect, it will find this instance of SQL Server running, and we can connect it. We can, of course, very easily start a second instance of SQL Server and just run it on a different port. So, for example, 14533. And this is one of the very powerful things of Docker. I've just started a new instance of SQL Server, and there's a very simple way that we can test this. We're going to do a Telnet test, so a slightly different test if you don't have SQL Management Studio, just so you can see that it's working. So if you don't have Telnet installed, you may need to enable the feature. You can just do a Google search on how to do that. I quickly did that. So it is Telnet localhost 1533, and you'll see, although it emptied the screen, there's something that happened there, and I can do the same to the original port that I added, and both those servers are running separate versions of SQL Server now, separate instances. So that is just a quick introduction into the Docker and the Docker command line, and how to get a rather lengthy install from SQL Server being much quicker and easier to manage and install using Docker. Step number 3. Let's run the Nginx Web Server using Docker. But now what we're going to be doing is we're going to be installing Nginx, which is a small web server, just to see how that would work. So typically how you would do that, you would go to the Docker Hub and search for Nginx, or you would go Docker Nginx. Doesn't matter how you search for it, but it should take you to the Docker Hub page. And in the page, it will give you some information about all the versions. And you can see you've got quite a lot of versions and supported platforms, what it is, it's a web server, and how to run it. We're going to use this example more or less, not exactly, but so what we would be doing is we say docker run, and the first thing we want to do is the port, and we're going to say 6060, and that means we are pointing port 6060 on our local host to port 80 inside the container. And the next thing we'll be doing is saying we want to run it in the background, and then we're going to say Nginx, and we want to run the very latest version of Nginx. Now, if you run a container like this, if the image gets updated, when you run it again, it will download the latest version, and you'll always be on the latest version. And this is really one of the reasons why you want to be using Docker. Now, what we'll see here is if we go localhost 6060, we'll see our Nginx server running. And it's just an index.html file that's now hosted here. So if we go docker ps, we'll see that it's running on port 6060. If we stop it, so the command for stopping the image would be stop a container, docker stop in the container, and that container means the ID. So we do docker ps, we get our container that we want to close. So we still have SQL Server running, and then we're going to say docker stop. And if we go back here and we refresh it, we'll see the site cannot be reached. And then I can do a docker remove, which basically removes the image from the ps-a site. So you'll still see there's a hello world that we ran. Microsoft SQL Server is actually still running, and this instance of the container is just a reference. So I can say docker remove, and I can just give it the name or the ID. And now if I do a docker ps, I'll see, okay, it's actually only running Microsoft SQL Server. Now I'm going to go back in my history, and I'm just going to start the server again, and I should be back up and running. Now, one of the really amazing things about Docker is that I can have multiple versions of my software running. So if I just go to my command line, and I'm going to duplicate the tab, and I'm going to change this to 7070. If I do a refresh, nothing is cached in my browser. A hard refresh, you'll see there is nothing running there. And I'm going to start another instance of Nginx on port 7070 on my local host. And if I refresh it, you'll see Nginx is running there and there. Now, you may ask, well, is it possible for us to change the file inside the container? Because now we can't see anything, we only see the container. The only part of the container for the moment that we can be seeing is what we're seeing here. There's no way to edit the files in it. So if we go back to our cheat sheet, what we can do is actually to go into the container with a command called docker exec -it. So, and then what we're going to be doing is we'll choose the container as 6060. It's the one we want to be working with. And the command in this instance, and it may be another command depending on the container, will be bin bash. And now you'll see it says root at that ID that we pasted there. And this is actually a Linux shell that we've entered into. And what we can be doing now is, because Nginx is running here, its install and configuration is usually in etc. Nginx, and the conf.d will basically tell me that there's a default file, and sorry, made a mistake there, cat cfall.conf, and I'll see that user share Nginx HTML is where the root folder is on this, of the Nginx server in this container. So if I go and change directory to there, and I do an ls, I'll see, oh, there's an index.html file, and I can try and edit it. Now there's usually an editor installed on most Linux distributions called Nano. Oh no, Nano command not found. So how would we install it? So we can go apt-get install Nano. This is something what you may think you can do. You may have done that before, and you'll see it's unable to locate the package. That's no problem. The images that we're running is like the smallest possible versions of Linux that you can find. Everything is removed to reduce size. So apt-get update, what this command will do is it will refresh the application indexes that apt uses, and then what you can do is we can just go up and we can install Nano. So once the indexes are refreshed, you can just say yes, and if I then go back in my history, I can then use the Nano editor inside the container, and I can say now edit and Control X, yes, and I'm just going to save the file. Now if I refresh 6060, you'll see Cornell edit, but if I go to 7070, it still has the original welcome to Nginx. And now the question is this actually persisted? So let's test it. We're going to exit out of the shell. We're going to do a docker ps. We still have our 6060 guy there, and we're going to go docker stop and docker remove. Let's just see what happens here. It should fail, and then we're going to remove the image or the container instance. And then what we're going to be doing is we're going to again instantiate it on 6060. And then what you will see is that the original is there. And if you were guessing that if we go back into the container, so we'll go to 6060. So remember it's docker exec -it, and we're going to run the bash command. And if we go / etc nginx conf.d cat default, I never remember the path specifically, and shouldn't have / and if we do nano on the index.html file, Nano isn't there, so now we have to install it again. apt-get update, and once that's finished, we can install Nano, and then we should be able to edit that file again. So let's just quickly do that, and I'm just going to change it back to now -edit and we're going to just save it. And if we then refresh this, Cornell edit is back, and I'm just going to then see what are we going to be doing next. So I'm going to exit out of the shell, and what we want to be doing, and this is relatively simple, so we've got our 6060. I am going to search for how to save a Docker image. Now I just say save Docker container to image, but you will find Docker commit, and Docker commit is super easy to use. So we're just going to go scroll down. You have to use the container ID, so we do docker ps, and we know the one that we want to actually save is going to be 6060. and we're going to say docker commit, and then we're going to give it a name, Cornell Nginx version 1. And now what I'd like to show you is another command called docker images, and you'll see, well, we've got the hello world image because we ran the application. We've got SQL Server, we've got Nginx, and now we've got a Cornell Nginx v1. Okay, and what's very interesting that I can do, so I've got 6060, 7070, so if we refresh it, it's still there. 7070 is still the original one, but what I'm going to be doing is running yet a new version of the server, but I'm not going to run Nginx. I'm going to run Cornell Nginx v1, and what will happen on port 8080, we duplicate this tab, we'll see we've got the changes we made were persisted to this image. And as you would expect, if we look at the processes, so we're just looking at 8080, we should still find nano in here. So if we do a docker exec -it, and we open the bash shell, and I just press Ctrl L on my Windows machine to clean the screen. So then I can go /etc nginx conf.d. I can even edit the default file, and nano is still there. And if I go to the index.html file, let's just change directory there. You'll see my changes that I made are still there, and I can make a change that's live in the container again that won't be persisted. So unless we do the docker commit. So yes, and if I reload this, it'll be Cornell 2. The 6060 will be Cornell edit. 7070 will be the original Nginx. Step number 4. Let's look at Docker volume mounts. Next, what we're going to be doing is we're going to be looking at volumes in Docker. And just for beginners, because this is a beginner's tutorial, the case that we want to look at is we've got the container running, as in this picture, and we want to share a folder on our file system with a container. So in the case of our Nginx example, the folder that has the website in it is called user share nginx html, and I would like to share some operating system folder with it. So in the previous case, I can actually go into the container and update the file, but what if I just want to share files with a container? And that's what we're going to be doing next. So the first things we're going to be doing is just to create a directory called website. And if I go to the website directory, well, I can get the full path of the website here. And then we're going to start a container. So we're just going to clear the screen. Okay, so it is quite simple. So what we are going to be doing is docker run, and we're still going to make our port 6060 and point that to port 80. And then we're going to mount this volume, and it is just our folder where we currently are, but I'm going to put it in quotes. So if you've got a path that's got spaces in it, it'll support it. And then we just need to have the path where the HTML file in the container is actually located. And we can run it in the background, and then we just send Nginx latest. Okay, so now if we go localhost 60, Okay, so now that we've shared the folder, if we try and access it, we get a 403 forbidden. We are still getting a message back from Nginx. So it means it's working, but in that folder that we've created, there's no files. So there's no index.html or any other files. So what I'll be doing is I'll be creating a new HTML file, and I will be calling it index.html. And let's just see. Let's create a header and a body. And we can just say in bold, it's file. And now if we refresh this, we'll find our index.html file. And at the same time, if we create a new file and we want to call it test.html file, and we can save it as test.html, then Nginx will serve that file for us. So that's kind of how you would share a file with a Docker container. And in this case, you've got a little web host with Nginx, and you can say share any HTML files that you'd like. Step number 5. Let's continue exploring Docker volumes. So we've looked at sharing a bind mount or a local folder with a Docker container, but Docker can also manage storage for us using volumes. So if we look at our little cheat sheet, we can see that there's a Docker volume command. And if we just run that, it'll give us all the commands we can run. So we can create, inspect, list the volumes, prune. So if we're not using it, we can remove it or remove a volume. So Docker volume ls, and that shows us we've got no volumes. So let's create one, and we can call it website volume. And if we then do an ls, we'll see the local website volume there. And if we go back to our host, it's not running at the moment. So what we can do is docker run -p 6060 pointed to port 80. The volume, we're going to call that website volume we just created, and we're going to mount it to the exact same point as we did before. Run it in the background, Nginx latest. And let's see what's happening here. Great stuff. It's working. The index.html is working. We should not have a test.html in there. And now we want to be able to copy the file we have in our website folder into this volume. So just the test.html for the moment. And let's go back to our cheat sheet. And we can see that we can copy the folder contents with this command. So what is our local folder? And we can just go like this. And what we want to do is go to website and choose HTML, test.html. So that's the file we want to copy. The container, I'm just going to do this. So I'm not going to put the correct container now because I don't know what it is. And the container folder is the exact same spot where the rest of the files are sitting. And if I run it, it'll give me an error. So we do docker ps to get the last bit. And then we can just put the container there. Okay, so now this command is saying copy the test.html file to this part of the container. And if I then do a test.html, I see my test.html file is working. Now, just to make sure that we've actually copied the file into the volume, let's do the following. We're going to stop the container and remove it. And then we can just refresh to see that it's not running. There we go. We shall see that it's forbidden or it can't connect, connection refused. And then we're just going to remount or rerun the command as before. And there we go, test.html is working. And if we just go there, we'll find the index.html. So let's just copy the index.html file. And hopefully that will overwrite it. Yes, that will. So it copied everything. So now if we do docker volume ls, let's see if that works. I think it has to be the other way around. We will see that we've got a mount point with some data in it, and we've now solved the problem of persistence in a couple of ways. Step number 6, Docker logs. So let's have a little bit of a look at a bit of the logs and troubleshooting. It's not too difficult to do. So for example, if I request a file that doesn't exist, cornell.html, it should give me a not found. But let's have a look if there's any information in the log files. So what we're going to be doing here is doing docker logs, the container ID. So let's get the container ID and we do docker logs for this container. And then let's have a look at what we're seeing here. So we're getting test.html, and here we can see that we requested cornell.html and the result was a 404, means it didn't find the file. And so it's quite useful to look at the log files when you're trying to debug a Docker container that's not working properly. And there's also another way to do this. So say, for example, we want to see the messages as they're coming in. So we just add a -f to it. So we do -f. What it will do then is tail the file, which means if I go here and I do, for example, this again, it'll just show me all the logs that's being generated as I'm doing the requests. If the requests are coming in, you can see it's showing me a log. So I can see real time what's happening in my container. Of course, the container has to write out logs for you to see what's going on. Step number 7, Docker environment variables. Okay, so let's look at something else. So we're just going to see, okay, the container isn't running. And what we're going to be doing now is just look at the environment variables. So if we say docker run -e, and we want to declare a environment variable that's available inside the container, and let's just call it test.env, and we set the value to Cornell. And then we're just going to run the container as usual in the background, and we can just do Nginx, which will do Nginx latest. Now I should be able to see that my index.html is there, but let's look inside the container. Wait, first I have to get container ID, docker exec -it, and we're just going to go into a bash shell. And let's see what is in this test environment variable. So we can go echo, and on the Linux shell, it is just doing that. And you can see that the value of Cornell has been passed in to the container. Now you may have environment variables that you would like to use in your software, and this is one way to set it. And step number 8, let's wrap it up. So let's wrap the Docker tutorial for beginners up by having a look at the commands that we have here. So we've looked at docker ps, ps-a. It's just to get a list of the containers. You've seen the docker run, and you give it the image and the tag. And the tag is, you usually have a tag like latest, and latest would be the default tag. But you could also have specific versions, and you can have multiple versions of your images that you're calling. Then, of course, we didn't have a look at -it, but we did an exec -it, which means it's an interactive command that we're running. So we're not going to look at that in detail. Of course, this -rm automatically cleans up and removes the image when you've run it. If you want to run it in the background, we've looked at it, it's the -d, and we've looked at stopping the containers. You can also kill the container. Then let's move on. So basically, let's list the container and stop that Nginx container that we have there. And I am going to remove it again. Okay, great. So also what we can be doing, so if we go to Docker images, it will show you I've got the Cornell Nginx one that I created before and Nginx. So if I want to remove the image, it's RMI, so which is not on our cheat sheet, but it's remove image, and then I can give it. So for example, if I want to remove the Nginx image, this will not work because it will say there's a dependent child, because I based my Cornell Nginx on Nginx. I first have to remove this one. And then I can, for example, remove my Nginx image. So what we can do then is, let's see what the image pull command is. So usually if you do a Docker run with an image, it will go and download that image for you and run it. But you can also just get the image itself and put it in your images. So what we would like to do is to tell it here Nginx, and if we don't give any tags for Nginx, it'll automatically choose the latest. And you'll see it, it's busy downloading the image that we were using before. So there's a couple of other image commands that we're not going to be looking for in this introduction or the beginner's tutorial. You can actually build your own image. You can log into other repositories, for example, Azure repositories instead of the Docker Hub. You can actually push images that you create to a repository, and you can of course remove the image. So now that's image removed, but the one I used is another shortcut. And then you can inspect and prune images. So in terms of the volumes, I think we can have a look at removing a volume. So we can docker volume ls. We still have our website volume here, and it is as simple as running the rm command. Now the volume is removed. So then on the troubleshooting side, we've had a brief look at Docker logs and Docker logs -f to tail it. There's a couple of other commands that's possible here. I encourage you to read a little bit about what's possible to do here. We're not going to be looking at Docker Compose for this beginner's tutorial, but this basically wraps up the Docker tutorial for beginners. It should get you going. You should be able to start a container, configure it, set options and environment variables for it. you should be able to get an image up and running. And you know, it's a great starting point to start experimenting with Docker. Thank you for watching this Docker tutorial for beginners. Would you like to leave a comment below? Remember to subscribe, like, and share this content. Thank you.